Hello, everyone. Welcome back. So I see a new name on the call. We should start with introductions as usual. And that would be Val. Is that short for Valerie? You could do like a quick intro, please. We aren't getting any audio. You're not muted, but no audio.
Can you hear me now?
Yeah.
Sorry about that. Good morning. My name is Val. I've been doing consulting work at Meta for about a year and a half. I'm working at infra, but my interest is also at diagnostics. And so this is just a learning experience for me.
I see. Thanks very much, Val. Welcome. Okay, that was all for the introductions. We can start with a quick status call as per usual. Let me see if there's anything in the status. I don't see anything. Igor, you didn't fill in anything on the status. I'm joking, obviously. I will do some name calling though. So since I just mentioned you, Igor, is there any update that you want to share?
Yeah, there is no update other than the fact that I finished the next round of review. So I'm waiting for more feedback. And that's all.
Got it. I think I replied to some of your questions, but I'll look again today or tomorrow. Thank you for that. Next up, Young. Any update you want to share on virtual client?
Yeah, so on the OCP schema side, so I made a change so that it's logging to one file, and maybe I'm going to share that next week. And I'm also talking with Sergey from Google, and I'll see if I can help Google and other people start using virtual client. Yeah, that's the update from me.
Is this Sergey? Is this Sergey Lysenko?
Yes.
Okay, that makes more sense. I got a request on Slack from Sergey, and I was wondering what the interaction is.
Yeah. Dan, do you have more context? Should I is Sergey onboarding virtual client to the hardware validation?
Yeah, Sergey is part of our team, and he's the person who's adding some of the virtual client benchmarks into our server qualification battery of tests. So we're looking to bring in some external things. We have tools internally, which you know about, called Perfgate, that we've used, and we're looking to see like what we can onboard and then what we might be able to push out there as well, which are benchmarks and sort of stressful workloads that we like.
Okay. Yeah, thank you, Dan.
Yeah, no worries. I do have one other quick question. I heard that you put all the results into one file, which is great. There were a few other things that we discussed as well, like the IDs, the fact that it's kind of expected to stream out, things like that. I was wondering if any of those changes were also sort of in the loop. Is that something you're working with Sergey on?
No, I haven't. Okay. But I will work closely with Sergey, and I also need some help from maybe Sergey as well, because the schema is new. Yeah.
If you'd like, I'll try to facilitate a meeting. If you could send over some times that are convenient for you, we'll try to accommodate.
Okay. Yeah, thank you, Dan.
Thank you.
All right. Thank you, both of you. I guess the next would be the LMT tools. Satish, Francesco, Hua, any update you want to share? I know we haven't had the meeting yet, but maybe you find something in the meantime.
No update yet.
All right, so we'll have that meeting. Go ahead, Paul.
Nothing on my end either.
All right, thank you. And I guess that's all I see from the call. If I haven't called upon someone, just raise your hand and we'll do that. So we have two things on the agenda for today. One, I'll start with the shorter one, which is a quick question. Do we want to have another 1 hour weekly meeting on more technical discussion and aspects? Any opinions?
Should we do bi-weekly maybe to start and then figure out if that catches on, then we can do more?
Frequency is, as we agree, bi-weekly seems fine to me as well. I know this is expensive, which is why I'm asking for opinions, right?
Yeah.
Yeah, I think we sort of seem to be organically doing it anyway, on demand. So, I think having the regularly scheduled sync, even if we call it off week per week, it may help because then we don't have sort of the scheduling conflicts of trying to get everybody in the same room. And honestly, having an hour block on my calendar that I don't attend every now and then, that doesn't hurt me either.
That was my thinking as well. Like, for example, this call on the LMT stuff, which is, we're still exploring how to map the hardware and endpoints and all of that. This needs to happen, and we will probably have similar topics in the future for other diags. So, having a block that you can skip is arguably better than not having a block that you need.
Yeah, so if we do this, Satish, Wah, would you guys want to be our inaugural next meeting to see if we can get the final details worked out on the LMT, or are you guys able to work it out in the background? I'm sorry, I don't have any visibility in what you guys may be discussing in other channels.
Yeah, I think sounds good to me, but I think this time, can you hear me?
Yeah.
Yes.
Okay, so yeah, so this 8 a.m. slot in PST is kind of tricky for me for technical discussions. This is typically my shuttle timing. It'll be good is that if there's anything like 10 a.m. PST, yeah, I'm all in for that time slot.
Yes, I'm also available at that time.
Okay. Does that work for you, Adrian?
So most of the people are in US time zones, right? Apart from Karen and maybe Giovanni used to join at some point. Francesco, you're also in MPK, right? Anyway, the point is, maybe we can shift it a bit later in US time zones, not at 8 a.m.
What about noon, folks? Does that work? It's a block that most people have open on their calendars.
Yes. Does lunch include?
Well, maybe what we
Yeah.
can do is do 30 minutes so we have a little bit of time to eat as well.
So noon is 4 hours from now. 11 p.m., 11 a.m. maybe for you guys would be 7 p.m. in Dublin.
That works perfectly for me.
Karen, what do you think as a representative from Dublin?
Personally, the 7 is a very poor slot for me. Of all the evening times. So because it's it's no 7 is poor, I would say. 8 is better than 7 for me.
8 is better than 7.
Yeah, they're both poor, but 8 is better of the two.
Okay. I'll make another of those quizzes or whatever calendar things, and everyone can vote, and we'll see what works. Okay, so that was the quick question. 45 minutes, Dan, are all yours.
Okay, I don't think I'm going to need 45 minutes, but to give a quick introduction for the topic, we were discussing, I think 2 meetings ago after I came back from Taiwan, we were going to do a quick presentation on the HWI. That's the hardware interface we basically use to get machine data. And I wanted to present it here because one of the challenges that we're running into is we've got a lot of people that are using the Python version of OCP DIAX v2, and we don't currently have a hardware interface in that for right now. So what does this cause? It basically means the diegs that we have right now, like we can run them in manufacturing and we can run them externally for like hardware validation and things like that, but we're not able to bring them into to our data centers yet. I think this is something that we would have to provide probably, but I wanted to see, give a quick intro and see if there's other interest in this. The primary thing that it gives us is a way of getting a unique hardware identifier, right? So if we want to call a device something that, you know, doesn't change if you install a different operating system, or doesn't change if, you know, the parts in the box move around, like this is sort of that stable ID and where we get it from. So that being said, let me see if I can figure out how to present on Zoom or whatever this is. I think you might need to give me permission to share.
Everyone has that already.
Okay.
But if it doesn't work, I can make you co-host. Okay.
Let's see what happens. Can you guys see my screen now?
Yeah.
Okay, and do you see it? I can't see you guys anymore. Is it full screen now, right?
Yeah, the HWI.
Yeah,
Okay.
we can see everything.
Okay. So you guys have seen this drawing before, right? This is one that we presented actually way back in the original OCP diegs presentation that we did at the Global Summit. But here we've got the diag on the left. We've got the hardware abstraction layer, what we used to call the HOW, now we call the HWI for the hardware interface. And then you have a configuration file. And what that does is it sort of tells the how do you go and get the data about the machine? And there's several different options here that we have. We have a host backend, which is just sort of like a collection of generic Linux utilities that should run on just about anything. We have custom host backends, which would be for very proprietary things, like maybe we're working with a particular accelerator or something that has its own API. An instance here might be like the data center GPU manager from NVIDIA, possibly, right? We have the Redfish backend, which is like sort of an open standard. We have custom BMC backends. Most of these actually speak Redfish as well. There's a few BMCs or things that we call HMCs that speak their own protocols, but the backend can really be anything. It's however you want to get data from the machine. The only thing the hardware abstraction layer does is keep your diag from being tightly coupled to that. Because there's another thing that we sometimes run into where we use different backends for different environments. So this was the level of detail that we went into at the Global Summit. I'm going to go into some specific examples now. I wanted to see if anybody had any questions before we move on, though. Okay. Oh, sorry, Vincent.
Hey, Dan. Is this protobuf? You're probably going to get into that, but is that a protobuf interface to the layer?
It is today, and the protobufs will look very, very familiar to you once we start getting into them.
Okay,
Adrian?
cool.
So my question is, and maybe you will get into this, but just something to keep in mind. I'm kind of interested at a higher level than this. We're already getting into implementation. But if you think of this whole thing as a black box, so everything to the right side of the diag is a black box, what are the inputs, the outputs, and responsibilities of this? And does it run in a restricted environment, or does it need additional infrastructure?
So the first question about does it need additional infrastructure? If you mean external to the machine or the operating system, it does not. If you mean does it need additional helpers and things on the DUT, it does, right? There's things that help it get the information. In some cases, that might be as simple as like /sys on Linux, right? In other cases, though, it might need other utilities it pulls. It really depends on the backend. Every backend has its own dependencies.
All right, so by infrastructure, I mean additional services that may run on other hosts or whatnot. So
Yeah,
it's all local and it can be embedded in the diag, correct?
Yeah, that is true. I think the probably more correct way to answer your question is all of the existing implementations are local that we have right now, but there's nothing in the design that says it would have to be. Like if you wanted to go off to some like system of truth about, you know, your particular DUT, like that could be a back end, right? It would probably not be a great one because you would get your as expected versus your as discovered, but you know, it would work, right?
Okay. And on the embedding aspect, can this sit inside the diagnostic package? And alternatively, can it sit as a sidecar on the same machine that you talk to through some protocol?
It could. Today, for the most part, it is actually compiled into the diag, right, as a library. But we could make it a sidecar. The thing that's compelling about the sidecar is it kind of fixes our language issues that we have.
Yeah.
Yeah. Once again, like we'll kind of get to that because I think that is an important point. Like if you look at most of OCP diags, it's a really lightweight shim around sort of the output and eventually the inputs, right? This is it's a lot of code, right? It's not something that we could probably make language portable, right?
All right. Yeah, we'll get to this. Go ahead, Satish. Sorry.
Yeah, I think you answered my question already. So I was trying to see the problem statement. Like, what are we trying to solve here? So it looks like this is this a new thing, or we are trying to replace something which we already have, like HWI layer?
I would say what it really is we're trying to create device manager in an operating system agnostic way, right? That's really what it is we're looking for here.
I see. Okay, thank you.
Okay, any other questions? Okay, I'm going to get back into it here. So, this is sort of an example. I wanted to take a CLI to kind of make it a black box. We provide a CLI for this, but you can see like some of the info that we're pulling from the system here. We get data about CPUs. A dev path is that unique identifier that we use for parts, right? This would almost be like an OData ID in the Redfish world, but not quite. EEPROM information, things about system events. Most of these are about errors or things that were unexpected events that occurred. The fans, the firmware on the device, any type of field replaceable units, any part that you can take out and service in the data center without a soldering iron, all the hardware that's in the machine, the memory, data about the platform itself. That might be like the number of CPUs it has, things like that, the architecture. And then we've got commands to reboot the machine, sensor information, and then things about the drives and storage, right? I said drives. It doesn't necessarily have to be a drive, though. It could be like far memory or anything like that. So here's an example of actually going in and using that CLI to get some CPU information. In this particular case, I restricted it to one particular field topology. So we go in, we run it, we get back the pretty JSON message here. Actually, it looks like JSON. It's really not. It's a text protobuf. But we have the info, we have the number of sockets, how many cores are on the machine, the physical cores, the logical max cores. And in this particular case, we got that data from Redfish, right? But if I had, a custom backend like our GSys backend, it would pretty much provide the same information. This is sort of where we get that abstraction layer for where we go in and get data. So here's an example of get system info, right? I would call get system info just like what I did before. And then this is the protobuf that we have for that. I've simplified it a little bit here, right? But if you look down here at this bottom part of the message, you get a list of repeated identifiers that we call hardwares. If you remember back to the original OCP specification, this was one of our result types. That's now called a hardware info to make it consistent with hardware info. But you get the repeated fields of hardwares, you get the repeated fields of software infos. You get this concept that we call trays that we did not bring over into the OCP format, and then a list of plugins, and then also how many times that particular system is booted. Now, if you look at that hardware info object, it's going to look very familiar, right? It's really that OCP diags v1 message, if you remember back to that, where we had the dev path, we had the OData ID, the name, the arena, the type their names and improve things.
There's
a bit of a drop there about this.
Then we lost you for like 20 seconds.
Okay, sorry. I'll repeat, and I apologize. Can you hear me now?
No, you're kind of in and out.
Okay.
I think it's okay now.
Okay. So I'm going to repeat this slide. I'm going to do it quickly, though. So anyway, going through the get system info example, if you look at this particular identifier, this was really the OCP v1 message for what we called a hardwares at the time, which we now call hardware info. But it's all those fields that we had before, right? That's the data that gets returned here. Any questions about that? Okay.
Any reason why we need to change the name of the message from hardware info to identifier? Are we planning to use it for more than hardware?
No, so these are the old message names. We went through, this is what you would call OCP diag v1. This was before we had v2. These are the original Melton names, Satish.
Okay.
Yeah, we have not changed our hardware info to honor the 2.0 contract yet. We actually haven't ported any of our 200 internal sum diags to the new format.
Okay.
Is the idea that we would, like, that we don't have to mix and match here between the old and the new, do we, in this proposal?
If we decide that we get critical mass here and we want to bring this over, I think that would be the logical conclusion, right? Is that we would move all this stuff over. It's a lot of work for us, but if there's interest outside of Google in something like this, right? That's probably where we would end up.
Okay, and then the other question is, we're talking a lot of proto here. Does that mean that all of a sudden we would add proto as a requirement to basically author any diag?
What we would probably do is that we would keep the protos internally, but we would probably go ahead and turn those into JSON or something equivalent on the output so that people don't need to deal with the proto.
This question goes into the language aspect, so we can discuss this later.
Okay. So I talked a little bit about how there's multiple backends. There's that configuration file, if you saw on the very first slide. For the most part, it looks very simple. It looks like this. You give it a backend type. In this particular case, there's a backend redfish. And then there's a default backend, which in this particular case is a very proprietary Google thing called Jesus for Google System. And what this allows us to do is we have some machines that are made up of multiple nodes. The OCP, or I'm sorry, not the OCP, the DMTF terminology for this would be computer systems, right? But in this particular case, we have two computer systems that make up the system. One is a local BMC. Our BMCs run Linux. They run OpenBMC. And then we have the computer itself, which is running a different backend. And then what happens is in this hardware interface, it combines all of that stuff together to make it look like one large logical system. So we don't have to worry about like unique names or anything like that. The hardware interface does most of that for us. And then how does a backend work? So I'm going to take an example for Redfish here because it's very open. We have a configuration file where we basically specify like what is the RPC. It doesn't need to be an RPC. In this particular case, it's an HTTP request. And then all the fields from that particular request that we want to pull. Each backend has its own sort of like custom translator layer. This is what it looks like for Redfish. But for instance, here I'm trying to get CPU info. You can see I'm going in and I'm doing a subquery of CPU. So if you think about the Redfish device tree, if you're familiar with it, that's what it's going to pull. It's going to pull all these particular fields, and then it's going to also do some subqueries to get other additional information that we need, where it'll go pull cores and threads and things like that. So the sort of takeaway here is that that one function call from the HWI may actually be dozens of function calls on the back end of whatever your source of truth here is. Daniel?
Yeah, you mentioned Jesus is proprietary, so I guess you would not be open sourcing that backend, but all the other backends that you showed on the first slide, and I think you had some ... there on the first slide, would all the other backends be planned to be open source other than Jesus, or which backends are you planning?
I think there's two that make sense. One is the Redfish backend because it'll literally work on any Redfish enabled thing, right? Like we've used it on HP machines, we've used it on Dell machines, we know it works, right? The other one that probably we could open source, although it might introduce some problems, is the one that we call the host backend. And this is really just a collection of like Linux utilities, right? This is LSPCI, LSCPU/sys, and just kind of walking that and everything else. It's been extensively tested. Well, it's been tested extensively, might be pushing it, on a system that we call OVSS, which is like a Yocto-based distribution that we provide to our partners and things. So we use as like a reproducer for external issues. It probably works fine on Fedora or Red Hat or any of the other like major Linux distributions, but it hasn't been tested, right?
No.
I suspect there might be little things that break from this version of that utility or this version of that utility, things like that. But we do have some pretty good unit tests, or I should say integration tests for this. So if it was broken, we would find it pretty quickly.
Okay, and the Redfish backend would cover OpenBMC. Is that compatible with the OpenBMC implementation? Okay.
Yeah, that's what we use. Although we've used it on non OpenBMC as well. For instance, we've used it on HPE's BMC, which is iDRAC, I believe. Is that right, or am I confusing? Anyway, but yeah, it should work on anything that speaks Redfish. The one thing that we do run into with Redfish is there's a lot of folks that have special things implemented in OEM properties. The OEM properties are like our artifact extension where you can just kind of put anything you want in there. We do grab those, but they don't sort of come across as structured in the API. They become a list of pretty much just like key value pairs, right? So they're there, but it's kind of hard to depend on them, right?
Okay, thanks.
No problem. Let's see here, and I think that's my last slide. So that's sort of an example of how we use the hardware interface and what it does. Vincent.
Again, yeah, quick question on the Redfish one. It's a bit of a double click, to be honest. Hopefully, quick question. Does it handle differences in versions emitted by DMTF on Redfish?
That's a good question. It probably doesn't handle it very well, is what I'm thinking. I think what I would say is it will handle forward-looking versions pretty well because the DMTF's pretty good about like adding things, or when they change things, they usually give you a pretty good backwards compatibility story. But if you had like a very old version of Redfish that didn't have a field that we were relying on, I suspect it would generate an error. Adrian?
So I'm gonna start the complicated topic of how portable this is and how it's compiled and languages and the JSON serialization, inputs, outputs, and all of that. So if there's something else before we begin on this, now is the time to raise it.
Yeah. Disclaimer, if you get too deep, I might need to bring Shufeng in here to kind of answer some of your questions, but I'll do my best.
Yeah, I'm intrigued about just what does it look like? What's the developer workflow? I'm trying to start a diag. Am I now compiling in all the different languages? Am I having to not talk directly to my API and instead talk to this API? And am I writing code on the back end to implement my fetching and parsing of the output, etc.?
I'll tell you what the story is today, and then I'll give you a couple possible futures that we could look at, right? And then we could probably discuss like, does anybody even have interest in this, right? The future or the present today is that all of this is implemented as C++. And it's a lot of code, I'm not gonna lie, right? And then we have language bindings for it, right? We've got a Python binding. So that would mean that you would basically, have to have this precompiled as an SO, and then we would go in and you'd have your Python binding and everything else, right? And it should just work, I think. But Shufeng will have to keep me honest about that. Now, if we wanted to try to eliminate that, right? Like where you have to build it or compile it or anything else, then the two options we could do is we could do the sidecar service, as Adrian suggested, like basically run this thing as a daemon separately, in which case you're just making JSON calls to it or something like that. That has one advantage in that you only deploy it once. It has disadvantages as far as versioning goes, right? Like this is a problem where, diag A expects this version, diag B expects this other version, which is why sometimes compiling it in is good. Or the other thing that we could look at as well is going through and Well, actually, to be honest, that wouldn't work either. That would be too hard. I think if we really wanted to do it, it would probably be best done as an external service, in which case it becomes a shim on top of other services, I think.
Yeah, could you linger on that one a little bit more then? So with the protobuf service, is it the case that today, when somebody's writing a new diag, they embed the calls to the hardware interface, but it is not emitting an RPC call. It is actually inline and querying the underlying OS? Or is there actually a model where it is emitting an RPC protobuf call to get the information from, say, a remote system?
And none of the backends today use, or well, actually, I guess in a way that's not true. Like if you were using the BMC backend, it would be calling out to a remote system. It would be calling out to the BMC over HTTP, right? Now, whether you consider that remote, it is on the box, but it wouldn't have to be, right? We do have cases where we have BMCs that don't run adjacent to the computer. They're actually in a different power domain and everything else, right? Even though they're the BMC for that computer. I don't think that that's that unusual in the networking world. I think it's fairly unusual in the server world, but we do it.
But if you're trying to get CPU info of a particular device or a machine, then this is done in band.
No, not always. So like for instance, if we're using the Redfish backend to get CPU info, that is an out of band request for us. Like we could make that from another machine and get that information. It would be out of band. I don't need the computer turned on, for instance. Like I wouldn't even need an operating system running. I can get that out of band.
So your question, Vincent, I guess it's more of up to the driver, well, backends. You call them backends, not drivers. Up to the backend, if we have any remoteness, because after the backend, you can Redfish is obviously a remote call. You could have like a BMC in band or a BMC out of band. And the in-band obviously depends a lot on the hardware because I know different machines talk to the BMC differently from the OS. So I would say that the discussion or to the right of the backend drivers, maybe a better name, is reasonably out of scope here. We're kind of more interested in what goes into the diag package and if we go onto the sidecar thing, which I kind of want to get into this discussion. But go ahead, Daniel.
So is it fair to say that within Google, you mostly use the GSys backend that would be the one that you're not open sourcing?
Today, that is largely true. All of our systems were kind of based on GSys. I think we want to move to Redfish now. It doesn't do everything that GSys does. I mean, GSys is 20 years of development, right? But we do want to get away from the proprietary sort of like giant monolith that controls our system, right? GSys, for folks that aren't familiar with that, who are kind of joining the call, it's sort of like WMI on Windows, the Windows management interface, if you're familiar with that. It actually looks and does a lot of the same things for Linux.
So how much testing or how much usage have the other backends seen, the host backend or the Redfish backend? Do you think that those are stable or?
The Redfish backend definitely is. The host backend, I don't know, to be honest. That would be more of a question for Shufeng and what he's been using it for.
Okay.
Adrian?
All right, so I'll get into it. First of all, I was meaning to say thanks for the presentation. This was very useful to understand what's going on here. For my question with the black box thing, correct me if I'm wrong, but I want to get like a good intuition for what this thing does. If you treat it as a system, whether it's embedded or it's sidecar or on a different host, whatever, this is something that you would use to generate the hardware info objects, or at least the stable location field on those in what we use in the output right now. And if that's so, then I personally find a big value in having this, because that's been a pending question for the diag writing. Like, what do you actually put in there? How do you refer to a PCI card? How do you refer to the core 0 on the CPU on slot 0 or whatever? Before I go into the language boundaries, I want to ask Vincent, you're working on the manufacturing side of things. Do we have a good use case for this kind of utility in our pipelines? Because I imagine we have something similar on how to refer to the hardware. But if we were to use like the OCP test and validation output for everything, do you think it would be easier to ingest this behavior already and change the identifiers to match this, or to use this?
Yeah, I think today we have a gap in that area, and I think that the big win here is the alignment in running these diags in different environments, right? So if you single out manufacturing, you probably don't need this as much, but it's when you're doing work in a lab, in the data center, and in manufacturing that you really need this, because it's the repair workflow that comes in play in the biggest, most significant way. So yes, there is a project to work on this, and it's sort of the engineering. It's the right thing to do from an engineering perspective. In fact, Daniel had been scratching his head and got a bit sidetracked on this one, but he started to look into the hardware abstraction layer, and there is a need for that. So the short answer is absolutely, but it's a play much bigger than manufacturing.
All right. Well, that's exactly what I was getting at. So I guess this answers your question, Dan, right, with whether someone else wants to use this.
Yeah, and what you said, Vincent, exactly matches sort of our experience as well. Like in the manufacturing world, most people are like, just give me a serial number. And for unserialized components, like, it's small enough to deal with it. But when we get to the data center and, we have like 79 million cables and each cable needs a unique name, that's where we run into, problems.
So on this topic, I see you have your hand up, Marcus. On this topic, I would like it if there was a document specifying the stability of these identifiers and how they are stable to specific invariants. Because you can say, okay, it's stable if you didn't move the PCI card from one slot to another, or it's stable if you moved it to a different server, stuff like that, right?
Yeah, I can speak to that. With the Jesus backend, it certainly is, stable within the machine no matter what you do. There's no mutation you can do that will change an identifier. It's like a silk screen label is generally what we follow. So like if you put it in /dim3, it'll always be dim3, or if it goes into PCI 0 and there's a bunch of cables, we'll map all that out. But the stability is really going to be a function of the backend and how well it does that. Even with Redfish, for the most part, it uses OData IDs, and those OData IDs are sort of like logical identifiers rather than physical identifiers. We've had to do some work there, and it will work in OpenBMC to make them stable physical identifiers. But I can't say for sure, actually, I can say for HPE, like if you use HPE, it's stable as well. But I couldn't say for every backend everywhere that it would be stable with our existing implementation, right? So it's sort of you are at the mercy of what the backend or the device manager does, right?
Oh, okay. But I'm not saying we need to discuss this right now. I'm saying it should be documented because that's like an important aspect. Marcus, you are next.
Yeah, so historically this GSysD, HWI type thing has been an endless source of delays and churn for manufacturing, because you have the software developer who's responsible for keeping it up to date, requiring hardware that doesn't exist because we haven't built it yet, but we can't run the diag on it because it depends on the HWI for it to do the work. And so the thing that we've always wanted is to get as far away from this as possible and get just down to the as close to the metal as possible. So like this is definitely a step backwards for manufacturing, and also for the level of engineer that we tend to work with. And I don't mean that to knock anybody, but manufacturing test engineers tend to be more electrical engineers who write software, not SWEs who know how to test. And so then we end up like the level of coding skills required to effectively import and work with this complexity just makes things like much more complicated. And so that would be my feedback on where we've ended up.
Okay, I think it's more of a statement than a question, but
I do want to jump in. I think Marcos, I appreciate a lot what you're sharing here. It's a lot of loaded statements. Would you agree though that the problem is different in NPI versus mass production? That NPI is very much differently challenging than a mass produced system?
Absolutely, and I guess the question's more of how do we not repeat the same mistakes? What are we doing different, proposing to do differently? Because I know internally we spent a lot of effort trying to shift left and try to enable more and stuff development earlier and earlier, and so that we get this development out of the way of being able to complete an NPI and especially early hardware evaluations. So
yeah. I mean, I can answer your question. What we're trying to do is do mimic and try to simulate the system before the hardware exists so that we can, get the development started. But that's a whole science project that's not related to this. And then so far, to be honest, I don't know how well it's working.
Go ahead, Kevin.
Yeah, so there was this question about stability of the identifiers. For redfish, we have something called, we internally call it as redfish stable ID, which is a tuple, which is part location, context, and service label. So these two identifiers together, today we use them to internally map it to the dev path. So in terms of stability of the identifiers, I think this redfish entity or this redfish set of properties are identical to the dev path. And this is sort of part of the regular redfish schema, the DMTF schema.
Yeah, I think to add on to Kieran's statement, though, where we run into trouble sometimes is with that service label. Like the service label is intended to be like a silkscreen notation or something like that. But if you look at some BMCs, it's not always that.
Just a quick add to this. This concept of stable identifier, maybe we should rephrase it a bit into stable in the context of what? Because you can say, okay, this won't change the thing you want to identify if you're only talking about the host, or if you're talking about the rack, or if you want globally unique identifiers. I don't know, stuff like that.
These are host specific. These are host specific and even across the various nodes or computer systems within a particular machine.
Yeah, that makes sense. I'm just saying in that document where we talk about this, the scope, the context should be important.
Okay.
Vincent, I think you are next.
I'll give it to Daniel. I'll go after him.
I might have missed it in the presentation, but I'm just curious on what those identifiers look like. Are those human readable, or are there a hash, or?
Yeah, they are human readable. And it's going to look generally like, like for instance, if it's a dim, it's going to be dash or /phi/DIMM0 or something like that. But it really depends. Like if you have a lot of like external cabinets and things on your system, they can get pretty long, but they are very logical, right? Like it's sort of this connects to this, which connects to this, which connects to this, and we build a big string out of it.
Okay.
There's an example on the chat from Marcos.
Okay. Yeah. And you mentioned that they're stable as long as you're still in the same machine, but if you take that DIM and you put it in a different machine, then all bets are off. That is no longer stable, or?
Well, no, because it doesn't identify the component. It identifies where the component exists. It's like a physical location for the component. Like if we wanted to identify that specific DIM, we would do it by the serial number, right? This is more identifying that that particular DIM is satisfying the role of DIM2, for instance.
Okay, so
example would be like HGA0, you know, very logical identifier for a drive. Whereas what we would do is we would have it named like NVMe 0 / blah, 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 where it's hooked up at.
okay, but if the manufacturer says say swaps 2 of the DIMMs because there's a faulty DIMM and they want to test out if the failure follows the DIMM, then the name swaps because they swapped the location. So here we're just identifying location, not the hardware piece itself.
That's correct. And that's by design. That's so the technician can say, well, DIM A was bad and now DIM B is bad, right?
Okay.
Go ahead, Vincent.
Yeah, so I wanted to rewind a bit back when we started OCP test and validation. You know, Dan, you made it clear that the parameterization model, the hardware interface, you know, the structured output, that was the whole package, right? So we then focused on the structured output of the spec, and that was a deliberate decision. Now, my question, you know, comes back to what's the contribution model that we would be looking at with HWI, because some of the discussions we've had sort of off meeting is where to put the HWI. And I know there's various opinions that I think Adrian will get into with respect to PyPI and how it's built and the SO versus not. But maybe the consensus that I would like to understand here is, do we as a working group want to stand by supporting the HWI as an open contribution model, or do we just make it basically part of the DIAG deliverable and it doesn't actually get contributed to in the as openly, I would say, in a common fashion? So I don't know if that's jumping ahead a bit too much, but I'm sensitive to time, and I am curious on the opinions from the larger working group here on this.
I can, like, I'll give you my opinion because I've actually thought a lot about this. Like if we opened it up, like if you're opening it up and you're using the HWI, it's easy, right? If you wanted to add a new method and then ensure that that method works across every backend, it's daunting, right? And it is not something that somebody would do as a hobby, right? I think that the level of quality that we would need, it would be difficult to do as a sort of a shared contribution model. Now, if we focus on one backend like Redfish, like that would probably work, right? But if you focus on one backend, what do you need this for? It's just another abstraction layer that you don't need, right?
Yeah, I'm curious to hear from others as well on this. I know, Adrian, I maybe you can lead on that with sharing your thoughts.
Yeah, so kind of on this topic, we get into the discussion on collaboration model, right? There's a lot of complexity in this, and I need to start from somewhere, right? The language. This is the first thing, and this dictates the usage pattern. One of the things that I need to consider here is, does this impact usability for other people who will consume this project in open source? And having a specific build system kind of does that, right? The fact that we don't have hermetic builds, so that you could say, okay, this code was audited and it is acceptable and it resulted in this build, and you can just pick the pre-built binary. We don't have that. So we need a mechanism to build from source, given that most entities will have this requirement on auditability, right? So that's why this sidecar thing appeals to me now that I think about it, because it has a natural language boundary to it. you can have this extra thing that is implemented in whatever language or mechanism, and you can compile it separately. You don't need to like make the compilation of the diagnostics complicated due to this other piece that would go into the diag. This obviously has downsides, as you were saying, Dan. We need a protocol to talk to the thing. Is it a Unix socket? Is it over a TCP socket? The TCP is arguably more interesting because you could say, okay, my host detection thing, HWI, maybe I should call it, can run on a different host, and it only talks to the BMC and the Redfish towards my actual duty, right? So it would involve that model. But it has like more failure modes because your diag now says, okay, I can't talk to this piece sidecar thing that I need on the system. It's not installed, it's not live, whatever. So my diag fails in other ways, which is, you know, a thing that needs to be accepted.
Yeah, we have.
Yeah.
Sorry, go ahead. We have two documents because there's the HWI and there's another thing called the CMI, which is a communication interface for sending commands like run ls, right? Both of those we debated, you know, library versus service basically, and I can probably sanitize that and share it. It's very, very long, but it kind of goes through all the advantages and disadvantages to both and why we arrived at where we arrived, right? Not saying we made the right decision, but I can definitely say we debated it ad nauseum.
Okay, maybe we can have that discussion there on that, on top of that material. I am, you know, I'm trying to consider the collaboration model and the open source aspect of things. And while it works in this particular way, that doesn't automatically translate to everywhere else.
Yeah, I think because we only have 2 minutes left, the thing that I think is unique about this, like there's the one argument about complexity. I'm kind of like, there's open source video games. Those are very complex, right? Like I don't worry about the complexity. I think the thing that makes this distinct is it has to work across so many different types of hardware, and testing that is very difficult. Right? Like that's the thing that I think makes this unique and a challenge to open source. Now, that being said, Linux kernel does it, right? So it's got to be doable. But that's a huge project, right?
So, Vincent, I'll be 1 second. So to make a decision at this point, do we go forward with this and discuss the way we go forward, or is this like does it stop here?
So I want to ask that same question differently, Adrian. I want to say, can we actually do both? Unblock people that are like George that want to move forward and are trying to land, you know, more diags in the community, but not commit ourselves to make this part of the open model. And while we actually chew on this, because there's no reason we should hold back. This is kind of something we can choose to announce we're going to put in the public, in the open. But if we say we don't, that just becomes part of the diagnostic. I mean, as George pointed out, the hardware interface has been in OCP diag core for a while. It's just how we come forward to say, like, look, this is something we're announcing and we're going to support it. And so, you know, I'm kind of looking at the best of both worlds here.
So here's a quick question on that same topic. Can we have the same code trivially translated to a sidecar and be a lib at the same time?
You can, and that's actually in the document as well. I've got to run, but you know, the other thing to think about too is if Redfish becomes what we think it will become, like in 5 years, you won't even need this thing, right? Like that could be Redfish. But that would mean that all the diags and everything else we write only run on Redfish compatible systems, and we'd have to think about that too.
Can you make the documents available in the meeting notes then?
I can't because I need to sanitize them. So that might take me a little time, but I'll try to do that.
See you guys.
Thanks, everybody. Bye-bye.
Hey, one quick comment. I'll go from the other side of this as having to work with the diags. that work on our, the GSys thing, when it's in place and working and it supports your features, it makes writing a diag really easy. Like it abstracts all of the complexity of like, I don't care how you have to go about it. Just tell me what the serial numbers are for all of the DIMMs and all of the NIC and the thing. And in behind the scenes, all of that is kind of solved for you, and you don't have, oh, and here I need an I2C thing, here I need to read the through and look at these bits, and here I need to do this other stuff. All of that's just magically just works, and your diags become really much simpler in the complexity of the code that you write. But it's only because you've shifted all of that complexity to a different place that may be better, where that may be a better place for it. But it doesn't go away. We're just moving it around.
Oh, okay. Thanks, Margot. So in short, we want to use it now. We have to figure out how.
I don't know if we want to use it. I'm just giving you like the other, like I gave a pretty honest view on like the causes. When it doesn't work, then it's you have this chicken and egg, and it's basically the long pole that prevents an NPI for being ready, and you have an actual good test coverage at a factory. But when it's working, it's great. it's
okay. We want to use most of it and maybe add some improvements. All right. Well, in any case, we'll talk when Dan makes those documents available. Thanks everyone for joining, and we'll see you next week. Bye.
Bye.